Okay, in this short video I'm just going to show you how to find the location of an image in a plane mirror by drawing a ray diagram. So we're going to start with a simple object. Okay, we'll label this A, and we're going to be looking at reflecting this in a plane mirror. So we'll draw in the line representing our mirror. Okay, so this is the shiny side of our mirror here. This is the back of the mirror. So when you're doing this, the very first thing to do is draw a ray from a point on the object that's going to hit the mirror. So I'm going to choose the top of the object, and using a ruler, and just draw a straight line until we hit the mirror, and we'll just put a little arrow on there to show that that's the ray coming from the object towards the mirror. Excuse me. Now the next thing we're going to do is draw in our normal line. So where that ray hits the surface of the mirror, I'm going to draw in a normal line. Remember, that normal line has always got to be at 90 degrees to the surface of the mirror, and we always draw that in as a dotted line. Okay. And then the next thing we're going to do is measure, using a protractor, this angle here, and that's our angle of incidence that we've got just there. Okay. So using a protractor, we would measure that angle, and then we know from our law of reflection that the angle of incidence is equal to the angle of reflection. So we would measure that angle, and we're going to measure the same angle on this side. And we're going to draw the reflected ray. So in actual fact, this ray comes into the surface of the mirror and is reflected back out again. Now we're going to repeat that process with a second ray, which I'll just draw in a different colour. And again, we're going to start at the same point on the object, and we're going to draw another ray. And it doesn't matter where either of these rays hit the mirror, it's entirely your choice. So you have another ray coming this direction. Now again with this one, next thing we're going to do is draw in the normal line. Okay, so again at 90 degrees to the mirror, and again just represented as a dotted line. And then again this time I'm going to draw, measuring the angle of incidence just here, and then we're going to measure that with a protractor on the other side and make those angles equal. So there's our angle of reflection. So in reality, we know that the rays come in, strike the surface of the mirror and come back out, and over here is where your eye would be. So this is where you would be looking from. So those rays are going to come into your eye here and here. Now we know from what we have studied previously that in actual fact your eye always thinks that light travels in a straight line. So instead of your eye thinking that the ray it's seeing just here has come from over here, it's going to think that it's travelled in exactly a straight line. So what we do is we pop our ruler along the line, the reflected ray that we've just drawn, and we follow it back behind the mirror. Now because the ray doesn't actually go behind the mirror, it just appears to go behind the mirror, we have to represent this as a dotted line. Okay, the ray actually goes here and here, it never actually goes behind the mirror, It just appears to, it's just what your eye thinks is happening to that ray. And we do the same one with the first ray that we drew. So if we follow this one back as well, again with the dotted line because it's behind the mirror, you'll see there's a place where they both meet, just here. And this is our image, just here. So we would label that A dash, and that's our image. And if we look and we think back to what we'd learned about images in a plane mirror, the image is always going to be the same distance away from the mirror as the object is away from the mirror. So if we measure that distance, it's about 6 centimetres, and on the other side we've got 6 centimetres as well. So if you always follow those steps, you'll be able to locate any image using a ray diagram. This is what we call a ray diagram, because we're showing the incident rays and the reflected rays, and we're showing the virtual part of the image here. So because it is behind the mirror, it's of a virtual image. So if we're asked to talk about the nature of the image in a plane mirror, we can say it's upright. It would always be the same way up when we look in the mirror. It's laterally inverted. It's virtual. And it's the same size and distance as the object.